Well, it's great to be back here. You know, we've been suffering from conference withdrawal for the last 2 years, and it's so good to see all you guys. And I want to call out Dale on an outstanding theme for this conference, which is create the future. Because I think if we don't create the future, we're going to be victims of the future. We are under attack, and we're under attack. If you listen to Rob's talk, if you listen, you know, we're dealing with nation states who are trying to destroy our assets or trying to destroy our infrastructures. It's not science fiction anymore. We're dealing with a very nasty future, and we want to create a future where we're in control. And I think some of the most interesting talks I've heard in this was Tim Brown's talk, which talked about what it's like to be under attack from a nation state and how you respond, and I thought that was excellent. And another talk that I really was impressed with was Jen's talk Tuesday on the VEX standard on CSAF, and that is about the future. That is about what are we going to do to manage what I call the vulnerability tsunami. Now, what do I mean by a vulnerability tsunami, and why do I think it's going to happen, and why do we need standards like VEX and CSAF if we're going to deal with a future and create a future we want? Well, let me explain what I've been seeing over the last couple of years. Now, most of you know I'm sort of pretty deeply entrenched in this whole SBOM thing. And when I start to look at SBOMs, I start to see some pretty scary stuff. Number of you all know about PulseNet and seen the PulseNet product is made by one of the major vendors. And if you go out and you look in the National Vulnerability Database and you search for PulseNet, you'll find nothing. It's really clean. There's nothing wrong with it. It's perfect. Great. Okay. If you run vulnerability analysis like Gripe or a whole bunch of them against it, it's looking pretty clean. This is good. However, if you should happen to have an SBOM, whether you built it or the vendor supplied it, and you start to hunt that SBOM, you get a very different picture. Things go south really fast. This is just one example, and I see this over and over. I'll give you another example. An RTU. Ron Brash and I started looking at a particular RTU that's used in a large Midwestern pipeline. A lot of it. And again, go to the National Vulnerability Database, go to CISA. Until a week ago, you would have found nothing. Now you'll find some notifications and alerts on this product. But absolutely nothing until you got to look inside the components, and then things kind of go south. 244 vulnerabilities. So we're seeing this over and over again. And what we're seeing is this reuse of third-party components that aren't disclosed is hiding a lot of bugs under a big rock. Now, we've got a couple of ways we can deal with this. We can put the rock back down and pretend that those vulnerabilities aren't there. But if you, and I hear people, no, we shouldn't be sharing SBOMs because then that'll give information to the attacker. If you're dealing with a Russian government agency and you don't think they can generate all the SBOMs they want, guess what? The only person that is getting blinded and not getting the information when you don't know the components is the user, is the asset owner. All we're doing is blinding the defenders. But that's another whole talk about why I think SBOMs are so important. But we're seeing these third-party components showing up, and they're absolutely critical. And if you listened to Rob's talk yesterday, one of the takeaways was, hey, just because you're not using that Schneider or Omron product doesn't mean you're safe. The attackers are writing code that is generalized to go after code assist. And code assist shows up in a hell of a lot of product, and you don't know where it is. And you need to know that. So if you're a vendor, you need to be aware that you're shipping code assist. If you're an asset owner, you need to be aware of your code assist. Or you're just reading the vulnerability notes isn't going to do it for you. So we need this visibility into software. And again, we can go do the ostrich thing and stick our heads in the sand, but you can bet the agencies with three-letter acronyms in Russia are not sticking their heads in their sand. They're saying, hey, this is party time. They're getting the tool sets to be able to look and see what's in there. And so we're going to have increased visibility software. We have to decide whether we want to control that or manage that or have us managed by it. Now, I predict, and this is strictly a prediction. I want to work with my team and our data scientists, but I believe looking at the sample sets that when we get SBOMs and we start to look through them, we're going to see in this market probably an increase of 10 to 100 times vulnerabilities because of exactly the two examples I showed you a few minutes ago. It's going to be this tsunami of vulnerabilities. What are we going to do about it? Oh, and by the way, I should mention that you don't just go and look in the National Vulnerability Database when you get a component. It is really, that's another whole talk, and I'm happy to share a beer over like how tricky it is to find a component versus a vulnerability in NVD. But how many guys here or women here were controls engineers back in the 80s? Yeah, okay. So, Sam, you remember all the troubles we had with alarm overload, an alarm avalanche. You know, what was happening is that all the DCSs and all the control systems were producing thousands of alarms, and what did you get? You got operators in the control rooms who were doing this. Nothing was getting done. So there was a whole industry, and Kuzumano, you remember this too. There was this whole industry, like people like Eddie Habibi built tools to manage that avalanche of alarms so the operators could make intelligent decisions. Because as the title says, when everything is important, nothing is important. And to me, I actually don't care about vulnerabilities. I care about exploitability. When we go out and we say, you got to patch every vulnerability, that is missing the point. Exploitability is what matters. And so how are we going to do that? And this is where VEX and what Jans was talking about yesterday is really important. We need to get a model together for sharing exploitability information. It's not the vulnerability notice. So I'm going to give you a very personal example. When Heartbleed came out, I had now sold Tofino to Belden, and I was the chief technology officer for security products at Belden. And it fell to me to respond to Heartbleed, not just for Tofino, but for the entire Belden product line. So we had a pretty classic triage model. Okay, do we use OpenSSL? And there were some products that didn't, so we just communicated that to CSS predecessor, ICS, what was it called? ICS cert. So we communicated that to ICS cert. That was happy path. That was easy. But often we ran OpenSSL. There was lots of it. So then the next question was, do you have the vulnerable version? If no, yes, happy path. But 9 times out of 10, the answer was yes. Now is where the metal hit. You know, this is where the things got important. This is where we had to start paying attention. Was there implementation risk? Fortunately, in the Tofino, the answer was no, because the guys didn't compile in any Heartbeat code. There was a stripped version of OpenSSL. Easy answer for me, misery explaining to my customers. I don't know how many phone calls I had to explain that you don't have to take the whole package when you take an open source package, but it was nasty, and I spent days on phone calls. Yes. And now you've got to evaluate. And sometimes there was no impact because it just wasn't reachable in some of the Belden products. Sometimes it was really hard to exploit, so deal with it in another patch. And sometimes it was a crisis. But all of the time, it was always communicating this back to either CISA or the customers, and that took a lot of time. And you listen to also Tim talk about how much effort it was to communicate back to customers in an efficient manner. What did he say, 19,000 tickets in their ticket tracking system? I mean, so this is where I see what we need to do in the future, well now, is start to deal with this, what we're going to have this vulnerability avalanche. Now, if it ain't broke, don't fix it, I think is a real model in our industry. Dragos did a really nice report a year ago about vulnerabilities, and that most of them have no exploits. We actually see probably a bigger number than that. And yet I see directives coming out saying, if you've got a vulnerability over 5, you must patch it. And I'm going like, wait a second, patching, anybody in control systems knows that patching is introducing change. Change is risk. If we just blindly patch, we are putting more jeopardy on our system than the attackers. So we need to prioritize our patching, and we need to figure out how to do this. Okay, and this is where VEX comes in. This is where CSAF comes in. It's a way of figuring out what is exploitable and communicating that. So it's the Vulnerability Exploitability Exchange Again, it's a document. If you listen to Jens talk about this yesterday, it's a document. CSAF is a VEX, or sorry, it's a JSON document that allows suppliers to communicate to their users in a way that's machine readable and consumable so you can make rapid decisions. So say you're a large vendor and you have some software and you have an SBOM. Now, I'm not going to go into whether you've shared that with your customers or not. That's, again, another talk and another debate. But I hope you have an SBOM. If you don't, by the way, give me a call. I'll help you get an SBOM for your own products. But hopefully you got an SBOM. And then the next thing you're going to do is you're going to want to figure out what your risks are, and you're going to do that by comparing that to the National Vulnerability Database and all sorts of other databases. And you're going to probably find out you've got a lot of vulnerabilities. Now, at this point, you could just give them all to your customers, and you're going to cause panic in your customers. That's not a good solution. So what do? This is where you start to use your team to do an exploit assessment, work your way through, and that is the VEX document. And now you can produce a document that's very focused that can say, hey, Mr. Customer, if you have an asset of importance to you, then these are some vulnerabilities we think are important. That gets fed into the asset management system, and then we can make responsible, reasonable decisions about patching. And again, there's a very important point here in the Vulnerability Exploitability Exchange. It doesn't say, hey, I know your PLC over there is mission critical. That's the asset manager, that's the asset owner, that's the asset management system to say that PLC there is mission critical, this one isn't. So it has to be a combination of information the vendor has, which is what vulnerabilities are critical, with what the asset owner has, which is what assets are critical to drive those decisions. And that's why this is all done in a machine-readable fashion, because you don't want somebody reading a PDF. So what's in a document? Again, Jen's talked about this. It's basically starts with 3 sections. There's a vendor section, or there's a header, then there's a vendor section that lists the products, goes very detailed, and then a vulnerability section that basically allows you to say things like, yeah, this product is not affected, so a negative vulnerability notice in a sense, or this product is affected, or this product, very important, this one, it's under investigation. We are working on it. And then that gets bundled up into this JSON, and that gets handled off to the customer, and again, ideally to get imported into a patch manager or asset management system. Now, there's multiple use cases, but the 2 most important are which vulnerabilities affect the product I use in my facilities, or, like we saw back at Christmas, what products are affected by the vulnerability of the week, Log4j. So the one vulnerability, the Log4j use case, is you can go through an entire product family, and you can say, hey, no one affected, and hey, we don't know yet, we're still working on it. Or you can go the other way. Here's a specific product of interest, go through the whole National Vulnerability Database, and give me a report on every vulnerability and say if I'm affected, not affected, or don't know. Here's some typical documents being generated. Those use both those use cases for OSIsoft. The bottom one is specifically across the entire OSI product line for Log4j, and the top one is for particular product line, in this case Pi Vision, for all vulnerabilities known. Typical workflow that we see these being used for, of course, you've got an asset management system. And really, I have SBOMs and CVs, but really it's the VEX. That's what you want to be importing to the asset management. So it's a source of risk compiled with the source of asset criticality. Glue those together, and you get a reporting, and you can tie that in, and you can say, okay, here's the priorities. So to summarize this, basically, it's providing a method for you as an asset owner or an operator to focus on what is most important, what is high risk. Okay, not focus on the, hey, it's over 10 on a CVSS score, we have to patch everything, but to focus on the things that are dangerous. It's designed to be machine readable. I mean, if you want to turn it into a PDF, you can always convert a JSON into a PDF. I wouldn't recommend it, but it's intended to be machine readable and consumable. And again, you can use it and make and blend it into multiple products for one vulnerability, or multiple vulnerabilities for one product, or multiple products and multiple vulnerabilities, and you'll get something about that deep. So the idea is flexibility. Some things I haven't gone into here is there's lots of nuance on it. It'll say like it's not affected because and the reasons. Lots of places for putting comments like, we don't compile in heartbeat code, and lots of opportunity to put in details. I won't go into that. I want to instead invite up Stinson McElhaney. He is the global the global technology director at the Solar Turbines, Solar Digital at CAT, because they are using this today. The future is now for them, and I really want you to hear it from somebody who's actually using this technology. So I'd like to welcome up Stinson.
Thank you, Eric, for the introduction, and it's really a pleasure to be here. I'm an S4 virgin, I guess. It's my first opportunity, and I've really been impressed with the content and the presenters, and so I'm looking forward to coming back. I'd like to just share with you briefly what we've done for Log4j and VEX, and just to give you a little bit of context, Solar Turbines, for those of you who are not in the turbine business, are not solar-powered turbines. These are industrial gas turbines. We have various applications that support the oil and gas business, gas transmission, power generation. So this is really just like a notional picture of something I think everybody's familiar here with. This is an industrial site. That's a gas turbine package. We have the typical things you would find in that site in the process control network, like SCADA and DCS. We have a turbine controller and HMIs, historians, etc. So for our industrial IoT solution, we have data acquisition equipment and a network gateway, like many solutions out there. Bring it all back, put it into web-based and mobile-based applications. So the devices that we're talking about, where we use the SBOM and generate the VEX, are really the equipment that sits out within that customer site in the industrial space, the things that are most critical. So that would be our data acquisition device and our network gateway. So everybody's done this. As you can see, I've pulled out all my hair, but I think there's a few people that still have hair left. The typical CVE notification comes in this particular case, Log4j, and we end up doing what Eric just described and what everybody does. We go through and try to figure out which files are affected. Do we have the files on the platform? Do we use the code? Have we patched, etc.? And typically, this is an onerous process for engineers to manually grind through, trying to figure out where these things are, and you most likely might not even get it right to be able to get to that level of detail. And so being able to find it faster allows you able to fix it faster, which is really what we all want to achieve, is how do we get this done quickly, and then how do we communicate the status of that. So here's a simple flow of how this works for us. Developer makes code modifications, checks it in and out of Git repository, triggers a pipeline manually or automatically. Pipeline builds the package, and now we actually have the artifact. So we actually take the artifact, we manually put it into the aDolus platform, and it generates an aDolus and refirm and any other things that we need to have analyzed. And it generates for us the SBOM and the known vulnerabilities, information that we can now respond to, and breaks it all down. We then can go through and look at the vulnerabilities, and as Eric was describing, we can start to add some information around them, we can tag them, we can describe if we've patched them, if they're applicable, if they're not applicable, and as you see on the side, we can then describe for that particular CVE what the status is. In this case, known, not effective, and that is what can be shared. So, we also are using this, I think, in a slightly different way, where we're using it even as part of the development process. So what we see on the left is various versions of the product as we're getting to build and release the product, and we can then look at it even prior to release to see if we're in a good state, something that we're okay to deploy or not into a good state. And then once we are ready with that product, ready to release that product, we can go ahead and have more confidence in what we're deploying. So The SBOM and the VEX really allows us to both identify and then communicate clearly about the status of any known vulnerabilities. Erica talked about how do we convey results. Well, people still read PDFs, and so we haven't completely gotten away from using PDFs. We've got internal PDFs, things that maybe have more details than we'd want to share externally, and we're able to look at risk, we're able to look at additional information around that. We have, let's say, a customer-facing version of a PDF, something that maybe a management report could use, or for customers of ours that are not advanced or mature enough in reading VEX, which I think is a lot of the industry at this point, we have that customer-facing version. And then we have now the VEX version as companies adopt the ability to do that, to import it, and to have a machine-readable format, we can produce that for them as well. So, you know, it's all about speed, it's all about accuracy, it's all about transparency, and even the continuous monitoring aspects. So when we've broken down that package, when new vulnerabilities emerge, we're constantly looking at whether or not they affect our package. So there's a proactive nature to letting us know whether we're going to be affected by new vulnerabilities that are coming out. So, you know, the identification, it's more accurate. We're not relying on a human who's exhausted trying to grind through this and figure it out after hours or days. So we have that automated fashion. You know, it's not the needle in the haystack. And we have now another I'll say a more automated channel for communicating with customers via the VEX. And then like a little bonus, we're actually looking at licensing information as well, making sure that we're not deploying into the field a GPL license, for instance, something that's copyleft that would really change the nature of what we need to do with our code and product and committing back to communities, et cetera. So thank you for letting me share the story. And
what do you think?
Point
Some questions?
Yeah, any Q&A.
You guys know the rules. Come up to the mics. Anybody got any questions? We've got a few minutes here. Either they're rushing for the mic or they're rushing for the beer.
So my primary question comes to the evolution of exploitability. It sounds like, and I may have missed this with the previous talk, with VEX, we're looking at point in time. How is the intent to handle in a month, in 3 months, in 6 months when a new exploit becomes made available for our previously existing CVE?
You want me to? Yeah, sure. So we don't think VEXs should be static documents. You're going to be getting a continuous feed of VEXs as new information. I mean, there's that clause in VEX which is under investigation. You can bet if you see under investigation in there, you're going to be getting another notice, another VEX. So expect the VEXs to be sort of a continuous information feed.
So the expectation would be you could have a not vulnerable or not exploitable at one point, and in the future you may receive
I think that it shouldn't be whether exploitability tools are out there. It should be, hey, we've reviewed the code and we simply don't have heartbeats deployed. And by the way, in the VEX documents, there's lots of opportunity to put comments or the reasons why the vendor believes that it is not exploitable. Not that it isn't being exploited. It's not a is being exploited. It's a we believe this cannot be exploited. Now, I also believe that I make software that hopefully has no vulnerabilities, and I know it does. So there will be changes. But I think it is like vulnerabilities, it will evolve. You know, the notice today, or the alert today that CSAF puts out, CISA puts out is going to have revisions. If you make it machine readable, that's consumable. If you make it PDFs, it's a pain in the.
Thank you.
Yeah.
All right, thanks both of you for the great talk. Especially I was having flashbacks when you're talking about the CVE of the week and all your customers ringing you up and having to put out basically an advisory saying, this is how much we are or aren't affected. Do you think you're going to have to publish a VEX and then also publish like an email and a PDF for the people who aren't sophisticated enough to consume the VEX? And how much can you kind of automate that in the future?
Yeah, most definitely. I think what we've experienced so far is that very few organizations are ready to consume the VEX. And so there's also, let's say, the organizational approach to doing advisory, the legal review of how you describe advisory. So I don't think email really goes away. I don't think PDFs really go away. I think the VEX is a tool that allows us to assimilate all of this information much more easily, and so it becomes a great technical capability for, in our case, customers like an asset owner, an offshore platform that's having to go out to many, many different suppliers and look at all the equipment out there. It would be really impossible to effectively read all those PDFs. So yes, they're going to want the PDFs. Yes, they're going to appreciate the email to demonstrate you stand behind your products. But the brass tacks of making sure that you have an effective way to evaluate it, I think is going to come through automation. And I think the VEX piece of that helps with that.
Great conversation, and really appreciate you guys' presentation today. Kind of leading into some of the point you're making here about VEX and its adoption. I'd be interested in getting your opinions, sort of compare and contrast with like open source scanning technologies, Black Duck and others, because it does essentially some of the same things. Obviously, it doesn't have the JSON on the other side of it, but we're all living in an email world too. So just wanted to get your thoughts on that versus that. Does that make sense?
Yeah. So we have a number of clients who use both. Black Duck's a great tool. It does tend to produce a lot of false positives, so you got a noise. It's not a document that you want to hand out to customers. So really what we see, the opportunity with VEX and with the whole information flow is managing that information to make it, again, actionable for the customer. What my developers look at when I get a Black Duck report is and it goes back to those internal reports that you mentioned. I see Black Duck as being a very useful tool for internal, but then you want to take that data and absorb it into a way that your customers can absorb it. And so I see this all being part of an ecosystem.
Got it. So it's not an and or. it's more of a the internal versus external piece of it.
Yes, exactly. And aggregating it, you may be using White Source, you may be using Black Duck, you may have all these tools. You guys use a pile of tools, right?
Tons of tools. Yeah. For us, it's not a single thing that we use. It's an and. There's many things that we use. That also comes with challenges. Like I think about what we do in the cloud deployed software stacks. We have a secure DevOps process that uses JFrog and WebInspect and Qualys and a handful of other tools, and you get all of these different information, and now we have like this manual dashboard that we're trying to assimilate it and figure out which things are related, and so it's like, yes, you do need all the tools, but it also comes with challenges of trying to respond to knock down the number of vulnerabilities that are showing up in all those tools. So
Cool, thanks.
Hey, Eric, this is more of an SBOM question than a VEX question.
Okay.
But Stinson mentioned it, Log4j in December, everybody was scrambling around to figure out where they had Log4j. How were you able to quickly go back to the customers and tell them where Log4j was?
Well, this is where it's really handy to have those SBOMs all pre-built. And now you're just doing a big tree search. You're not looking just for the names. Like, not everybody is taking Log4j and calling it Log4j once they use that Java. So there's a lot of like pattern matching and markers. But at least when you have the SBOMs, you have a fighting chance. I mean, we were looking through about 35 million files to hunt for Log4j. It wasn't instantaneous. It was about 24 hours. And then you could throw a lot of different tools at it. But without the SBOMs, it would have been months. With the SBOMs, it really made the difference about being able to do this in a timely manner. And it looks like we've got 55 seconds. One last question.
Thanks for the nice reference to CSAF, Eric.
Thanks, Jens. Thanks for creating this.
I want to reply to the question earlier, which was about the automation of CSAF advisors or VEX documents. They are JSON files. You could put in some lines of Python, and then you get everything. You get PDF, you get HTML, text, whatever you want, and can completely automate it. And that's the beauty of these structured documents of VEX and CSAF. Thank you.
Yeah. Thanks.
thank you.
That's great. I think we're out of time.
This gentleman has
All
a
right.
question here.
Okay. Can we get away with another 15 seconds?
Yeah,
Okay.
quick question. In the architecture diagram, you showed the use of aDolus and Refirm Labs. Just curious what you're using Refirm for in that process?
Yeah, do you want to talk about
Yeah.
how we get additional depth with?
Yeah. So what we're doing is we'll be building these SBOMs, and then sometimes you end up with an SBOM or a product that's needs further analysis. So Stinson's team can then push a button and say, let's go deep analysis. And it'll push it to, in their case, it's Refirm, but it could be any one of a whole bunch of different static code analysis tools. So it's literally just an ability to, and then aggregate that information all back. So it's really about information aggregation.
Okay, thank you.
Yeah, for us, back to the earlier comments, multiple tools, having to manually aggregate this ourselves, using a single platform that can then reach out to other tools and do some degree of intelligence and aggregate it for us helps our engineering teams dramatically.
Well, thank you very much. It looks like we're out of time, and really appreciate your
Thank you.